Hello and welcome to another video from Plodware. In this video we're going to have a quick look at using the Adafruit Ft232H breakout board to drive a direct digital synthesis chip, the ad9850, which I believe is manufactured by Analog Device. The board is actually, I believe, of Chinese manufacture and is labeled the HC-SR08. We're going to use it to create a few fixed frequencies, a little audio sweep generator. We'll play all 88 notes of a piano. Just for fun, we'll play a major key scale and a minor key scale, and then we'll hook it all up to a shortwave receiver and do a radio frequency sweep generator. We'll be using the GPIO capabilities of the FT232. To make the demo run, if you want to do it yourself, you're going to need a PC running Microsoft Windows 7 or 10 or 11, a device driver for the FT232H chip, which you can get from ftdichip.com. I'll give you some more details about that in a minute or two's time. You'll also need the freeware interpreter, pwscripter from my website, and a customizing script for this demo. There is a disclaimer, a specific disclaimer. I have no connection whatsoever with any of the companies identified in red in the white box. My understanding is that Shenzhen Sunshine Sea Technology Corporation is the manufacturer of the HC-SR08 board. I have no connection with any of these companies, their employees, representatives, or subsidiaries. And this video is not sponsored. There is a disclaimer with this video. The video is for informational and educational use only. If you decide to use any of the components of this video, which are the WriteTech and Plodware applications, command scripts and documentation, then you do so at your own risk. There is a disclaimer, a specific disclaimer. I have no connection whatsoever with any of the companies identified in red in the white box. My understanding is that Shenzhen Sunshine Sea Technology Corporation is the manufacturer of the HC-SR08 board. I have no connection with any of these companies, their employees, representatives, or subsidiaries, and this video is not sponsored. I'll just introduce myself. I'm a retired telecoms engineer and I've been programming since 1971-72. That's enough about me. The demo. Let's dive in. There's some setting up that needs to be done, a little bit of hardware and a little bit of software. Let's have a look at the hardware setup. This is the front and back view of the FT232H breakout board. I found some useful documents. I've listed them here for you. You can get them from ftdichip.com. What I found particularly useful was the D2XX Programmer's Guide. And there's a few application notes, the 255 and the 113, which weren't too bad either. To use the FT232H board, we need a device driver. Specifically, we use the FTD2 XX device driver. You can get that from ftdichip.com. It's in a downloadable file called cdm212364 setup. It's a zip. Download it, unpack it, and run it as administrator. At the time of creating this video, I've had no problems with this driver or the setup. We don't need a driver as such for the ad9850, but there are some interesting documents about it, but we don't strictly need them for this demo. About the board itself, I couldn't find much information. By all means, try a web search, but it was not particularly successful. But it's a very common board, so there must be quite a few people using it. This is the wiring setup that we need to join the two boards. I've tried to lay it out here pretty much as it is on the breadboard, and just for reference, I've given you the view of the back of the board so you can see the pins. That the VCC, it looks like it's here, but from the front it's there. Ground I mark in white for the simple reason I'd like to do it in black, but a black on black won't show up. What does the layout look like when it's on a breadboard? This is what I'm using. The USB-C connector over here. Very, very important. This must be set to off. If you leave it set to on, it joins the two pins. It joins two pins together and connects them. This is the layout from the wiring for a breadboard. Please make sure you set this to off. Otherwise you'll get weird results. This was the output, which I either send to a simple mini audio amplifier, or I connect it close to the aerial of a shortwave receiver. You also have to set up PWScripter and the demo script. 2 slides. This is where you can get the PWScripter executable from. It's on my website. If you go to ripetech.com, downloads and script files, you will find a link there to PWScripter. It's a zip file. Download it, unpack it, and run it. This should appear. If this does not appear and you get this blue screen, Windows protected your PC, no big deal. Double right click on wherever you've put the executable in the file system to get the properties menu or pop-up. Select the general register and then down here tick unblock. That's all you have to do if you have the blue screen problem. That's setting up PWScripter. You need then the customizing script for the demo. Also, from the downloads and script files, you'll find a link to a simple text file. If you click on it on my browser, it opens up the text file immediately. And what I do then is copy and paste the online file's text into the edit panel. This is the edit panel of PWScripter. Or of course, if your system or browser is set up, download the text file, open it with a text editor and copy paste. That's all you need to do for the setting up of the software of the PWScripter and the demo script. Right, let's run the demo. Lights, camera, software. We can make that a little bit bigger. I've already downloaded the little script and put it into the edit panel. You might notice I've added over here a little meter. It's rectified, so it only works with DC. I've connected it up to the output, so if the output of this generator is slow, like 2 or 3 hertz, then we'll see the needle clicking across. Right, let's apply power. Plug in the USB-C. And let's go to the script and run it as far as the first stop. Execute. And there it's stopped. And check the output for 2 pulses per second. And yes, we can see the little LED, little meter flicking left and right. Now we will create a middle C and then play it for half a second, double the frequency, play it, double the frequency, and we'll play middle C and 3 octaves above it. Let's move this down a little bit. And there we'll play middle C, 1 octave above, another octave, another octave. So we'll put the mouse after the last stop and then execute from here. Okay. Now we'll make an audio sweep or a sweep generator. Now we'll get it to step from 0 hertz to 4 kilohertz in steps of a half hertz. So to do that, we call the sweep generator function. Start at 0, step of 0.5 hertz, do it 8,000 times. So execute from here. And it's finished. Now what we'll do is we'll play all of the 88 notes found on a piano. Let's set up the software, and here we go. And done. Let's play around, play a major key. Do, re, mi, fa, sol, la, ti, do. Now we'll do a minor key. No, a minor difference. Oh dear, terrible thing to say. A small difference between the two. Now we'll do a little bit of a reconfiguration. I'm going to connect up a shortwave receiver, connect its audio to our input, and we'll set it to the sweep generator to do 3.8 megahertz up to 3.804 megahertz in 1 hertz steps. Right. Here we go. Execute from here. Not too sure what that wow sound or where it comes from. Let's do the same thing now, but we'll do it in 2 kHz steps. This time I'll simply click on the command we want to execute. Execute the selection. And that's it. We'll turn the noise off. And that's the end of the demo. My thanks for your time. Until the next video. Cheers.